Determine the greatest common factor of each pair of numbers. So to do this, we will need to do a prime factorization of each number. So let's start with the first pair. So the first number is 35. Here we're going to be using the tree method, so we can factor this into 5 and 7. And that's it. 5 is a prime factor, 7 is a prime factor. The second number here was 42. We can factor this into 2 and 21. 2 is a prime factor. 21 can be factored further into 3 and 7. Okay, and now we have prime factors at the tip of the branches of these trees. What we're looking for when we're trying to determine the greatest common factor that these two numbers, 35 and 42, have in common is we're looking for prime factors they have in common. They don't have 5 in common. They do have 7, right? So there's a 7 here, and there's a 7 here. So the 5 wasn't in common, the 2 wasn't in common, and the 3 wasn't in common. That means that the greatest common factor, GCF, of 35 and 42 will be 7. The second pair of numbers was 50 and 70. 50 can be factored into 2 and 25. 25 can be factored into 5 and 5. Here are our prime factors. 70 can be factored into 7 and 10. And 10 can be factored into 2 and 5. And here are our prime factors for 70. We're looking for factors they have in common. So they have the prime factor 2 both in common. So we can write that the GCF is going to be 2. Then they also have a 5 in common, but only one of the 5s. There's a second 5 here that they do not have in common. And they also do not have the 7 in common. So we're going to do 2 times that 5 that they have in common. So 2 times 5 is 10. That means that the greatest common factor for 50 and 70 is 10. The next pair of numbers is 40 and 56. We do the division, the tree method again. Okay, so there are our prime factors. And for 56, we can divide it by 2, which leaves us with 28. 28 can be factored into 2 and 14. 14 into 2 and 7. So here are our prime factors. What do they have in common? Well, they have a 2 in common. So GCF equals 2. There's a second 2 that's in common. So times 2. There's a third 2 that's in common. Times 2. And then they do not have the 5 in common. They do not have the 7 in common. So this is the same thing as 2 cubed, which is the same thing as 8. So our greatest common factor of 40 and 56 is 8. Our next pair of numbers is 52 and 68. Okay. So here, instead of using the tree method, I'm going to be using the table method. It's just another method for prime factorization. So a prime factor of 52 will be 2. So we put the 2 there. 52 divided by 2 is 26. 26 has another prime factor. That's 2. 26 divided by 2 is 13. 13 divided by 13 is 1. So here on the left column, we have our prime factors for 52. The same thing for 68, divisible by 2. 68 divided by 2 is 34, divisible by 2, which is 17. So 34 divided by 2 is 17. 17 is a prime number, so it can only be divided by itself and by 1. So 17 divided by 17 is 1. And here are our prime factors for 68. So this means that our greatest common factor will be a product of the numbers that they have in common. So they have a 2 in common. There's a second 2 that's in common, times 2. And then the 13 is not in common and the 17 is not in common. So it's just simply going to be 2 times 2 is 4. So the greatest common factor of 52 and 68 is 4. The next pair of numbers is 36 and 60. Let's do the table method here again. Then we can divide this by 2 or by 3. Let's divide this by 3. 36 divided by 3 is 12. 12 divided by 2 or 3, both are prime numbers. We can do 3 again. 12 divided by 3 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. Same thing for 60. Prime factor here is going to be 3. 60 divided by 3 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 5 is 1. So for the greatest common factor, they have a 3 in common right there. So we're going to have 3. The second 3 that we have here is not in common. There is a 2 here that they have in common right there, times 2. There's a second 2 here, and they also have that second 2 in common, so times 2. And then that's it. The 5 here is not in common, so our greatest common factor is going to be 3 times 2. We can actually write this as 2 squared times 3, just to a bit shorter. So the GCF here is going to be 2 squared is 4. 4 times 3 is 12. And the last pair of numbers are 54 and 81. And let's do the table method here again. 54 divided by 2 is going to be 27. 27 can be factored into 3. 3 is a prime factor of 27. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. '81 can be divided by the prime factor 3. So 81 divided by 3 is 27. And then we can factor out the 3. 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay, so our greatest common factor here, we have, there's a 2 here that they do not have in common. So all of the prime factors here for 81, they are 3. So the 2 is not in common, but 3 of the 3's are. So it's going to be 3 cubed, which is 27. So our greatest common factor for 54 and 81 is 27.